Welcome dear students. Today's topic is mineral resources and economic development. Learning objectives. After the completion of this module, the learners will be capable of recognizing the primary metallic and non-metallic mineral resources of the world, grasping the spatial arrangement of important minerals, discussing the economic importance of minerals of industrial development. Introduction to minerals. Minerals are naturally occurring inorganic substances originating from the earth crust, defined by their chemical composition and distinctive physical properties. The major sources of minerals is magma, but some find their way through sedimentary burial and metamorphic processes. The mineral processes of the earth crust determines the presence and the difference in minerals. Minerals are universally found in connection with the rocks that are composed of minerals through geological processes such as volcanism, erosion, deposition, and metamorphism, among others. To understand minerals, one need to be aware of the geological conditions such as temperature, pressure, and chemical environment. In fact, minerals are not only geological occurrences, they are also important economic resources as they supply raw materials to various industrial sectors like construction, energy production, and technology. Their distribution is not uniform around the globe, hence different regions are specialized for certain types of minerals and they trade with neighboring regions. Therefore, minerals create a very important connection between the physical geography and the economic development aspects. Thus, they are situated right in the middle of the economic geography study area. Classification of minerals. Basis of classification. Physical properties. The classification of minerals is heavily reliant on the physical properties of the minerals as these traits facilitate the identification and are in fact the basis of the economic usefulness of the minerals. Among these properties, color, strength, density, luster, and texture, which are all easy to observe without the use of chemical testing, come first. Color is the most common and the first visual sign that a mineral can give, albeit sometimes a misleading one, as due to the presence of impurities the color may change. Hardness is the measure of a mineral's ability to resist scratching, following the Mohs scale, which is the most widely used for this purpose. Density is a measure of a mineral's weight compared to its volume and it facilitates the identification of heavy metallic minerals right away and non-metallic ones lighter in weight. Luster is the term used to describe light reflection of the mineral surface. The separation of minerals according to their physical properties makes it possible for geographers, miners, and geologists to spot the minerals easily and evaluate their monetary potential before their thorough use test is done. Basis of classification. Chemical composition. Chemical composition is the most important scientific and trustworthy creation in mineral classification because it indicates the chemical elements and the compounds of one mineral. Each mineral is then classified according to its most abundant element that can be iron, aluminium, copper, silicon, or even carbon. For instance, all iron minerals make a group while silicate minerals form another and so on. This method of classification not only helps to identify the nature of the mineral but also the industrial usability, its extraction methods and consequently the processing techniques. Moreover, the mineral's chemical composition is a decisive factor in its behavior during smelting, refining, and manufacturing. Moreover, it determines the mineral's resistance to weathering and its applicability in specific industries. The classification based on chemical composition is an aspected norms in geology and economic geography because it assures reliability of information about the quality of the minerals, its economic values and the technological requirements. Henceforward, chemical classification becomes a significant factor in the supply and demand of industrial raw materials and thus in planning and development of the resources. Metallic minerals. Metalliferous minerals are basically those minerals that are comprising of metal culminants and are able to yield metals when they are processed. They are responsible for the industrial growth, infrastructure development and technological progress. Metallic minerals are usually characterized by their high density, high luster and good conductivity of heat and electricity. The manufacturing industries like steel, engineering, transport, defense and electronics depends on these minerals. Their global distribution of metallic minerals is not uniform because of the geological processes which create regional specialization and international trade. Moreover, based on the presence or absence of iron, they can be further divided into ferrous and non-ferrous minerals. The extraction of metallic minerals is a long process that requires huge amount of capital, advanced technology and energy. Their economic importance is associated with the role they play in the industrialization, providing jobs and generating national income. Countries that have a lot of metallic minerals are also the ones that witness industrial growth and economic development with a faster pace. Ferrous minerals. Ferrous minerals are metallic minerals whose chief component is iron. Iron ore is the most significant ferrous mineral and it has varieties such as hematite, magnetite, limonite and siderite. Ferrous minerals are the backbone of heavy industries, especially the iron and steel industry. Steel made from iron ore is not only used in the construction industry but also for making machinery, transport, equipment and even for infrastructure projects. The main reason for the widespread use of ferrous metals is their strength, durability and eventually ability to be alloyed with other metals. Countries with ancient geological formations are the major producers of ferrous minerals. The presence of ferrous minerals led to industrial growth and economic development. In contrast, mining and processing of ferrous minerals require large investment and can cause environmental impacts. However, the ferrous minerals continue to be necessary even with all these challenges for modern industrial economies. Non-ferrous minerals. Non-ferrous minerals are those metallic minerals that are devoid of iron. Some examples of such minerals are copper, bauxite, zinc, lead, tin and tungsten. Non-ferrous minerals are trustful for their anti-corrosion characteristic, lightweight and good conductivity. So they are usually very high priced. Copper is the main raw material for electrical and electronic industries, aluminium for transport and packaging, while zinc and tin are relatively important in the manufacture of alloy and coating. Non-ferrous minerals are the main resources of modern technology, renewable energy system and advanced manufacturing. Their global distribution is limited so that the demand becomes high and trade between nations is developed. The process of mining and refining non-ferrous minerals is usually very energy consuming and requires advanced technology. On the other hand, these minerals are pointing quite significantly towards economic diversification and industrial innovations.